Quantum physics is a branch of science that explores the behavior of matter and energy on the smallest scales, such as atoms and subatomic particles. Many of its concepts defy our conventional understanding of reality, offering mind-bending insights into the nature of the universe. Over the years, quantum physics has led to groundbreaking discoveries and theories that continue to challenge our perceptions of the physical world. Here are 10 quantum physics theories that will truly blow your mind. 1. Quantum superposition. One of the most mind-blowing principles in quantum physics is superposition. It states that particles, such as electrons, can exist in multiple states at once. This means that until they are observed, a particle can be in several different positions, energies, or even have different spins simultaneously. It's only when we measure or observe the particle that it collapses into one definite state. This bizarre concept is famously illustrated by Schrödinger's cat paradox, where a cat in a box can be both alive and dead until the box is opened. 2. Quantum entanglement. Quantum entanglement describes a phenomenon where two particles become linked together, no matter how far apart they are. When one particle is affected, the other responds instantaneously, even if it's light years away. This defies classical physics, which states that information cannot travel faster than the speed of light. Einstein famously called it spooky action at a distance, and although experiments have confirmed its existence, the mechanism behind it remains one of the greatest mysteries in physics. 3. Wave-particle duality. Wave-particle duality is the idea that particles, like light, can exhibit both particle-like and wave-like behavior depending on the experiment conducted. Light, for instance, can act like a wave, as seen in interference patterns, but it can also act like a particle when it interacts with matter, as evidenced by the photoelectric effect. This theory was one of the key developments in quantum mechanics and is foundational to our understanding of the nature of light and matter. 4. The many worlds interpretation. The many worlds interpretation, MWI, suggests that all possible outcomes of a quantum event exist in separate, parallel universes. According to this theory, when a quantum event occurs, the universe splits into multiple versions, each corresponding to a different outcome. This means that every time you make a decision, the universe branches into multiple realities, with each possibility playing out in its own parallel world. It's a mind-bending view of reality that challenges our understanding of existence. 5. Heisenberg's uncertainty principle. Heisenberg's uncertainty principle is one of the most famous principles in quantum physics. It states that there is a fundamental limit to how precisely we can measure certain pairs of properties of a particle, such as its position and momentum, simultaneously. The more accurately we measure one property, the less accurately we can measure the other. This principle suggests that at a quantum level, nature itself is inherently uncertain and that absolute precision is unattainable. 6. Quantum tunneling. Quantum tunneling is the phenomenon where particles can pass through barriers that, according to classical physics, they should not be able to cross. This occurs because of the wave-like nature of particles at the quantum level. When a particle encounters a barrier, there is a non-zero probability that it can tunnel through it, even if it doesn't have enough energy to surmount the barrier. This strange phenomenon is essential in many processes, including radioactive decay and the functioning of modern electronics like transistors. 7. The quantum Xeno effect. The quantum Xeno effect is a paradoxical phenomenon where the act of continuously observing a quantum system can prevent it from evolving. In other words, if a quantum particle is measured frequently enough, it will remain in its initial state and not undergo any changes. This effect has been demonstrated in various experiments, where particles seemingly freeze when observed repeatedly, challenging our classical understanding of time and observation in physics. 8. Quantum computing. Quantum computing harnesses the principles of quantum superposition and entanglement to perform calculations far beyond the capabilities of classical computers. Unlike classical bits, which can be either 0 or 1, quantum bits, qubits, can exist in multiple states at once. This allows quantum computers to solve certain types of problems, such as factoring large numbers or simulating molecular interactions, much faster than conventional computers. Quantum computing has the potential to revolutionize fields like cryptography, artificial intelligence, and material science. 9. The Casmir Effect. The Casmir Effect is a phenomenon that arises from the quantum fluctuations of empty space. According to quantum theory, even a perfect vacuum is filled with virtual particles that constantly pop in and out of existence. When two uncharged metal plates are placed very close together in a vacuum, the fluctuating energy between the plates is different from the energy outside of them. This results in an attractive force between the plates, known as the Casmir force. While incredibly weak, this effect provides a fascinating glimpse into the nature of empty space. 10. Quantum gravity. Quantum gravity is a theoretical framework that seeks to reconcile the principles of quantum mechanics with Einstein's theory of general relativity, which describes gravity. Quantum mechanics works at the smallest scales, while general relativity governs the large-scale structure of spacetime. However, the two theories are incompatible in their current forms, leading to the search for a quantum theory of gravity. One leading candidate is string theory, which posits that the fundamental building blocks of the universe are not point particles but one-dimensional, strings. Quantum physics has unveiled an astonishing array of ideas that stretch our understanding of the universe. From particles existing in multiple states at once to the possibility of parallel worlds, the strange behaviors of quantum particles offer profound insights into the very fabric of reality. As scientists continue to explore these theories and discover new ones, quantum physics promises to keep us questioning the nature of existence for many years to come.